In this video, we're going to start talking about amortized loans. In this next sequence of videos, we're going to talk about how we talk about borrowing money, say from a bank or from a car dealership or what have you, where we talk about paying off a borrowed amount over time. So probably want to pause now so you can write down this first part, and then we'll have a chat. All right, so let's motivate this idea with an example. Let's say you borrow money from a friend today. You need the money today, but you're going to pay the friend back with payments over the course of the next 4 years. So we've got the sequence of payments in this case where we're going to pay $300 back 1 year from today, $200 back 2 years from today, $500 3 years from today, and $400 from 4 years from today. Given an annual effective interest rate of 6%, can we figure out how much money you borrowed from your friend? So this is an example of what we refer to as an amortized loan. Rather than borrowing a chunk of money now and paying it all back with interest at the end in one big payment, we're going to pay down the balance over time with smaller payments. So each of these payments that we're making is going to involve something that knocks down the original loan amount plus some interest for whatever entity, in this case your friend, but a bank or a car dealership, whatever entity needs to have interest payment as a service payment, if you will, for lending you the money. So this is an example, like I said, this is an example of an amortized loan. This would be the time value diagram in this case. $300 at the end of the first, $2 at the end of the second, $5 at the end of the third, $400 at the end of the fourth. So if we want to figure out the loan value, well, again, the loan amount in this case should be the present value of these payments given the annual effective rate of 6%. So our initial loan amount, which we're going to denote L sub 0, and in subsequent videos what we'll see is that the loan amount at any given time, or the remaining loan balance at any given time, will be L sub whatever the time is. Since this is the initial loan amount, we'll have L sub 0. Again, we've got to step back the $300 1 year, the $200 2 years, and so on down the line. Doing that in this case, using our usual formula V equals 1 over 1 plus I, we get a loan amount of $1197.67. So this is, again, a very specific example of how we get an amortized loan. Now, in general, when you make a student loan payments back, or when you make car payments back, or when you make mortgage payments, when you get a mortgage on a house, these type of amortized loans typically have level payments. And you've already studied how to do level annuities. And that's essentially what paying back an amortized loan is. You are paying back, basically, what happened is whoever lent you the money purchased an annuity from you, and you're going to pay the annuity back, essentially. So if L sub 0 is the loan amount, and this PMT, this is book's notation for payment, the PMT is the payment amount due at the end of each period, and I is your period effective interest rate, then the initial loan amount has to be the present value of all of those payments. And notice this looks like your usual annuity idea. Each of these are at the end of the period. So your initial loan amount will simply be the payment amount times the present value, A angle N, of I. And we'll see in subsequent videos how we can use this formula to figure out payment values and even loan amounts from this. So we'll see that in next videos.